Okay, welcome back to Mr. G's lab. So, we're basically going to talk about coefficient relationships and the mole. So, the mole is named after uh, Amadeo Avogadro, who was a chemist. He basically did a lot of gas laws. Um, and but what he also realized was that there was ratio. So, um, for example, H2O. H2O has two uh, two hydrogens and one oxygen. Now, when we combine when we combine different compounds into a formula, let's take 4Fe, this is already balanced, plus uh, 3O2 to yield 2Fe2 and O3. What we're saying is that for the coefficient is equal to the number of moles in a balanced chemical equation. So there are four moles. We abbreviate moles to MOL. Why we don't add the ES, I don't know. Um, uh, but there are 3 moles of O2. So there's 4 moles of Fe and 3 moles of O2. Not 3 moles of oxygen, but 3 moles of the compound dioxide. Um, and that there's 2 moles of Fe2O3. And that there are, let's move this up just a little bit, that there are, so the moles of Fe, and this is why I gave you all a rounded periodic table, was to make the math that you're about to do a lot easier. So 1 mole, 1 piece of oxygen. So we have, I'm sorry, 1 piece of iron is, so iron's atomic mass, oops, atomic mass, times the pieces. So its atomic mass is 56. We have 4 moles, 4 moles of, so 4 moles, so 56 times 4 is 224 moles. I'm sorry, yeah, 224. Its atomic mass for 4 moles equals 224 grams per mole. Okay, so we have 4 moles, so it's going to be, its atomic mass is going to be 224. Oxygen has an atomic mass, so we're going to look at oxygen has 3 moles times the atomic mass, so moles times the atomic mass, which is 16, times times the number of pieces. So pieces. So so times the number of pieces is going to be 2. So 16 times 2 is 32. Times 3 is 96. So we have 96. So 3 moles. 3 moles equal of O2 equals 96 grams per mole of O2. Just so that we know that it's Fe over here. So now we have one more thing. So we would have 224 and then if we look at the number of moles for the atomic mass for our product, that would be 50. So 56. So I'm doing for Fe2O3. Okay. So this is for this right here. And then the middle section is on the right hand side. So if we were to look at our iron for Fe2O3, so I'm just going to put that here, Fe2O3. So we have an atomic mass times the number of moles, which is 2, times the number of pieces of iron in Fe2. So that would be pieces. So that would also be 2. So 2 times 2 is 4, times 56 equals 224. If we look at our oxygen, so let's look at let's look at O2. So the O2, so we have oxygen of our oxygen atomic mass is 16 times the number of moles, which is the coefficient, which is 2, times the number of pieces, which is the subscript, that's 3. So 16 times 2 is 32, times 3 is 96. So we have 224 grams per mole on the reactant side for iron, and we have 96 grams per mole for oxygen. And on the reactant side, on the left-hand side, for oxygen, and we have the same number on the product side. So we have, this is a new concept I'm going to talk to you about. It's listed here, but the law of conservation of matter. And the law of conservation of matter says that nothing can be created or destroyed. It's just rearranged or made into something else. So we can take 4 moles of iron combined with 3 moles of oxygen to make 2 moles of iron to oxide, or iron, yeah, iron 2 oxide, I'm sorry, iron 3 oxide. You get the 3 from the subscript over on the right hand side. So, but iron oxide. So, the basic rule of thumb is that the coefficient equals the number of moles, and that you figure out the atomic mass. You take the atomic mass. For this formula, you're going to have to I believe it's balanced too. Yes, it is balanced. So you're going to basically have to figure out what the atomic mass of 2 moles of mercury is in order to answer your question. Um, One other thing is that 1 mole equals 6.02 times 10 to the 23rd atoms of mercury, of atoms of an element. So half of 6.02 equals, so 0.5 moles equals 3.01 times 10 to the 23rd atoms of an element. And that, ladies and gentlemen, is what we need to be focused on for the law of conservation of matter, and for lesson 75, and for coefficients and moles. So if you have questions, text me or email me. If you are not in my class, leave a message below in the comments, and I will return I'll return your answer as quickly as possible. So thanks a lot. Have a great day, and peace.